Okay, in this video I'm going to go over some questions to help you get ready for the test. And we're going to simplify radicals, multiply, add, subtract, divide radicals, and just take a look at what's called rationalizing denominators. So let's begin with the first question, and I'm going to look to see what number is in the crook of the symbol, and I don't see anything. So that implies that it's a square root. So what I'm going to look for is a perfect square factor embedded in the number 54, and that's going to be the number 9. The square root of 9 can now be changed to its equivalent of 3, and your answer will be 3 times the square root of 6. Let's take a look at the next one, which is not quite as easy because the number is a little large. And the number in the crook of the symbol is the index number, it's 4, which means we're looking for 4 of a kind. What I do know about the factors of 1600 is that 16 is a perfect fourth. If you didn't know that, then you can kind of play around with it a little bit, break it down, or use your calculator. And so I can write that as 2 to the 4th. I also broke 100 down because I wanted to make sure that there was no 4 equal factors present in 100. And as you can see, as I broke it down into the primes, we have a set of 2s and 5s. And what we're really looking for is a set of 4 of a kind. We don't have it. So the answer is going to be 2 times the 4th root of 100. All right, let's take a look at the next question. This one involves variables. Now the ones with variables, what you simply need to do is take the index number and divide it into the exponent of the variable. And then if there's any remainders, those stay underneath the radical sign. I call them the spares. So first of all, the other thing here about the number 125 is that it is a perfect cube. It's 5 times 5 times 5. So when I take the cube root of 5 cubed, I'm going to get 5. And then when I divide the 3 into the 6, I'm going to get a 2. So there's no spares left over. 3 goes into 6 evenly, so the answer is going to be 5x squared. The next problem, you see I've already started it. 45 has a perfect square factor embedded in it. It's 9. And then again with my variables, I'm just going to take the index number, which is not present, which means it's a 2, and divide it into the exponent. You can see with the y, it doesn't have a pair, so I call it a spare, which means it's going to remain underneath the radical sign. But that square root of 9 can become a 3. I can take out an x, and the 5 is also a spare, and the y is a spare, so those stay underneath the radical sign. Okay, let's take a look at the next one, which again, we have a nice perfect square in that, 36. And then we can take the index number 2 and divide it into 5, and there will be a remainder. And we'll take 2 and divide it into 6 on the y. And as you can see from that, I'm going to break this down just to show you visually what's going on. I have a pair of 6s. For every pair you can take one out. And there's one, another one. There's the spare. Okay, and then the y. Another set of y, and another set of y. And you notice that there's not a spare y. Again, a shortcut way here would be just to divide the index number into the exponent, and you get the same exact answer. So our final answer is going to look like this. Okay, so let's move on. This one, again, you're going to look for a perfect square factor embedded in 28. It would be 4 and 7. And again, I'm going to take the number 2 and divide it into 8 and 10 on that x and y. And we're going to get 2x to the 4th, y to the 5th times the square root of 7. Again, if you're wondering where the 4 and the 5 came from, you take the index number, you divide it into the exponents, and if there's any remainders, they stay underneath the radicals. But again, 2 went into 8 and 10 evenly because they're both even. Okay, moving on. This one's a fraction, and what you can do with fractions is you can tear them apart or put them back together again. So I'm going to show you that if you were to rewrite that as the square root of 9 over the square root of 25 and then just take each one's square root, you're going to get an answer 3/5. You didn't necessarily have to do it that way, but it's just easier visually to see what's going on with that. The more you do, the less you're going to have to do that. Okay, so the next one again, we have the following. And if I break it up into 2 separate radicals and then look for a perfect square factor embedded in the 18, that would be 9 and 2. The square root of 49 is a perfect square. So my final answer is going to be 3 root 2 over 7. And that's the way you would leave your answer. Okay, the next one, we're looking for the fifth root. Now this one can be a little bit tricky. You need to notice that you can divide 64 by 2 to get 32. And that's going to give you the fifth root of 32 over the fifth root of x to the 10th. Now notice that I did put them under two separate radicals, and that's perfectly permissible with multiplication and division. That's the beauty of multiplication and division. I know that 32 is a perfect fifth. It's 2 to the fifth. And so again, when you have the index number matching the exponent, they cancel each other out because they're inverses of each other. And then you're just going to simply take the 5, the index number in the denominator, and divide it into the 10. And you're going to get 2 over x squared. Okay, the next one, again, when you have two separate radicals, whether it's multiplication or division, try to put them underneath one radical, or one roof, as I've said in class. And when I combine these, I get x to the 12th, which is going to be much easier to simplify now, because all I have to do is divide the 3 into the 12. There's no leftovers, so nothing remains underneath the radical. Okay, number 11, again, what I'm going to do is same thing. I'm going to put that underneath one radical, and you better know that 8 is a perfect cube. It's 2 cubed, and now both of those 3's on those the 2 and the x are going to cancel out with the 3 and the index number, so your final answer is going to be 2x. Okay, one more for this video, and this time I'm looking for a perfect fourth in 625. Now, if you break that down into 25 and 25 and then keep breaking down into primes, you can see I've got 4 of a kind. So I can take that 625 and rewrite it as 5 to the 4th. Again, those 4's are going to cancel each other out. And you're going to, for the x to the 8th, you're going to take the index number 4 and divide it into 8. So your answer is going to be 5x squared. I will continue the rest of the problems on another video. Hope this was helpful.